From the roadway, the crossing feels uneventful. Cars pass in steady lines. Trucks hold their lanes. There is no visible edge, no sense of urgency. The asphalt behaves as it does everywhere else. Only when the camera drops does the scale reveal itself. The river below is a thin, distant line pressed into shadow by sheer rock walls that fall away for hundreds of meters. Sound disappears into depth. Wind moves differently, here lifting and cutting across open air where nothing interrupts it. The bridge does not rest on the gorge. It ignores it. For generations, this gap slowed everything, people, goods, time itself. Detours stretched into hours. Valleys remained close in distance and far in reach. Now traffic moves across in minutes. The structure feels permanent. The void beneath it does not. This is not a story about speed. It is about what happens when height stops being a barrier and becomes part of the everyday landscape. Building a bridge is usually an act of proximity. Two edges meet. Distance collapses. The ground offers something to push against. In Guizhou's karst terrain, none of that applies. Here the gap is not wide so much as it is deep. The gorge does not invite connection, it discourages it. Rock walls plunge toward a river that offers no foundation and no forgiveness. Wind accelerates through the channel. Weather shifts faster than forecasts can follow. From the rim, the opposite side is visible, yet functionally unreachable. And yet the decision was made to span it. The paradox is not the bridge's height alone. It is the intention behind it. This structure was not built as a landmark or an experiment. It was designed to carry ordinary highway traffic commuters, freight schedules across a void that once dictated the pace of life for entire regions. Suspension bridges belong to places where anchorage is reliable and access is manageable. Here towers rise from steep, unstable slopes. Cables stretch across open air where nothing exists to correct error. Construction takes place where there is no ground to stand on, only space to negotiate. From above, the bridge reduces the gorge to a line on a route. From below, it exposes the scale of what has been ignored. Everyday movement passes over a landscape that still resists presence. The contradiction settles into a single question. What does it mean to make routine use of a structure that depends on extreme conditions remaining constantly under control? The answer is not given in design drawings or statistics. It emerges slowly each time traffic crosses a height that once defined the limit of passage and no longer does. Guizhou's challenge was never a lack of distance. It was an excess of interruption. The province sits within one of China's most complex mountain landscapes. Karst formations fracture the terrain into steep ridges and deep gorges that repeat for hundreds of kilometers. Rivers cut downward rather than outward. Roads are forced to follow contours that twist, descend, and climb again. What appears close on a map stretches into hours on the ground. For decades, this geography translated directly into economic delay. Freight moved slowly and unpredictably. Perishable goods lost value before reaching markets. Industrial supply chains avoided the region altogether, favoring flatter corridors elsewhere. Tourism existed, but at a scale limited by access rather than demand. The cost was cumulative. Each detour added fuel time and risk. Each mountain pass introduced weather vulnerability. When a road closed, alternatives were not nearby. Entire counties could be isolated by a single landslide or seasonal storm. Development did not stop because of policy. It stalled because movement could not be trusted. Incremental fixes reached their limit. Improving mountain roads reduced danger, but not distance. Tunnels shortened routes, but multiplied cost and construction time. Bridges built lower in valleys solved local crossings while leaving the larger pattern intact. The network remained fragmented. As national transportation corridors expanded elsewhere, the gap widened. Regions with direct highway access integrated into faster cycles of trade and investment. Guizhou fell behind not in capability, but in connectivity. The problem was no longer local inconvenience. It was structural exclusion. Pressure built quietly. To integrate the Southwest into national logistics, travel times had to compress dramatically, not marginally. Goods needed to move on schedules measured in hours rather than days. Detours could no longer be absorbed by pricing. Reliability became the threshold. The gorge crossed by the Beipanjiang Bridge embodied this problem in its most concentrated form. It forced a choice between long, inefficient routing and a single decisive intervention. Skirting the terrain preserved safety at the cost of speed. Spanning it directly inverted that equation. The necessity did not come from ambition alone. It came from arithmetic. When every alternative carried compounding inefficiency, the only remaining option was to bypass the terrain entirely, to treat depth not as something to descend into and climb out of, but as something to pass over in one continuous movement. The bridge did not promise transformation by itself. It promised alignment, bringing a fragmented region into the same temporal rhythm as the rest of the network. That promise was enough to move the project from possibility to inevitability. Before the bridge, the gorge dictated a slower logic. Crossings existed, but they belonged to another scale. Ferries moved when water levels allowed. Low bridges hugged narrower sections of the river, forcing roads into steep descents and sharp climbs that punished engines and drivers alike. Mountain roads clung to slopes winding through villages that learned to live with isolation as routine rather than exception. These solutions were not temporary. They were the product of decades of adjustment. Communities adapted schedules to weather. Freight planners built buffers into every journey. The region functioned, but only by accepting delay as normal. Attempts to improve these routes followed a familiar pattern. Roads were widened, guardrails added, surfaces reinforced. Each intervention made travel safer without making it fundamentally faster. The geography absorbed improvement without yielding advantage. Lower bridges reached their limits quickly. Spans had to be short to anchor safely, which meant descending deep into valleys and climbing back out. Time savings disappeared in elevation change. Tunnels offered relief in some areas, but karst geology complicated excavation. Caverns collapsed unexpectedly. Water intrusion delayed work. Costs escalated beyond what incremental gains could justify. Over time, the region accumulated infrastructure without integration. Individual links improved while the network remained broken. A faster road led into a slow one. A new tunnel emerged onto an old descent. Efficiency leaked away at every transition. These past efforts were not failures. They were constrained by what was possible at the time. Engineering prioritized contact with the ground roads, slopes, foundations that could be inspected and corrected easily. Height was avoided because it multiplied uncertainty. What changed was not dissatisfaction with these solutions, but recognition of their ceiling. No amount of upgrading could remove the fundamental penalty imposed by terrain that forced movement down and up again over and over. The memory of those limits shaped the decision to build higher rather than closer. The past did not argue for restraint. It demonstrated that staying within traditional bounds guaranteed stagnation. By the time the bridge was proposed, the lesson was clear. As long as crossings remained tied to the valley floor, the gorge would continue to control movement. The only way forward was to accept a different risk, leaving the ground behind entirely. What made the bridge conceivable was not a single invention, but a convergence of tolerances. Suspension design matured to a point where height no longer multiplied uncertainty in the same way. High-strength steel cables could carry greater loads with smaller margins. Aerodynamic modeling reduced the unknowns of wind behavior in narrow gorges where gusts accelerate unpredictably. Movement could be anticipated, not merely reacted to. Surveying changed the relationship to terrain. GPS and laser measurement fixed positions in space where visual reference failed. Towers could be aligned across open air with precision that earlier generations could not maintain over such depth. What once depended on line of sight now depended on data. Construction methods adapted accordingly. Cable spinning across a void became manageable rather than theatrical. Temporary catwalks and pilot lines established control where ground access was impossible. Segmental deck construction allowed weight to be added incrementally balanced on both sides, reducing stress during assembly. Equally important was confidence in monitoring. Sensors embedded in the structure would track load vibration and movement continuously after completion. The bridge would not simply be built and left to endure. It would be observed, adjusted, maintained as a living system. This did not eliminate risk. It reclassified it. Height was no longer an absolute barrier, but a variable to be managed over time. The gorge became a factor in calculation rather than an obstacle to avoid. Engineering shifted from resisting exposure to operating within it. What tipped the decision was not certainty of success, but containment of failure. With modern materials and modeling, potential problems could be detected before becoming catastrophic. Maintenance could be planned rather than improvised. The turning point was subtle but decisive. The bridge no longer required faith that conditions would remain stable. It required systems capable of responding when they did not. At that moment, building across the gorge stopped being an act of defiance against geography. It became an exercise in continuous supervision acceptable within the logic of modern infrastructure. That shift allowed height to be treated not as danger alone, but as an addressable condition. Construction begins where the ground is least cooperative. Tower foundations are cut into steep karst slopes that offer little forgiveness. Rock is fractured, layered, unpredictable. Excavation proceeds cautiously, stabilizing each step before the next can begin. There is no flat staging area, no wide margin. Equipment is lowered, anchored, secured. Every operation assumes gravity is waiting to intervene. As the towers rise, the gorge asserts its presence. Wind behaves differently at this height, funneled and accelerated by the canyon walls. Work schedules bend around weather windows, measured in hours, not days. Crews pause, not because tasks are finished, but because conditions have turned momentarily hostile. Once the towers stand, the most exposed phase begins. Pilot lines are carried across open air, establishing the first tenuous connection between sides. From these lines, thicker cables follow spun strand by strand until the main suspension's cables take shape. Each pass crosses hundreds of meters of emptiness. There is no redundancy. At this stage, only balance and sequence. The deck does not arrive whole. It appears in segments lifted from below or guided from the edges, each piece maneuvered into position with precision that tolerates no improvisation. Weight is added symmetrically, inching outward from the towers. The structure learns its final form, gradually responding to load as it accumulates. Below, the river continues unaltered. From the valley floor, the bridge seems impossibly distant, a thin line suspended where nothing should hold. Sound travels strangely. Machinery echoes upward and disappears. The scale disorients. What is routine above feels abstract below. Logistics stretch across the region. Materials arrive along mountain roads not designed for their size. Scheduling becomes choreography deliveries, timed to construction windows that cannot shift. Delays cascade. Progress is cumulative and fragile. Safety becomes an active system rather than a protocol. Workers operate in harnesses where missteps cannot be corrected. Platforms sway. Tools are tethered. Training assumes exposure as a constant, not an exception. The margin for error is measured in millimeters and seconds. Time itself behaves differently. Days are productive or lost entirely. Weeks compress into visible change, then stretch into waiting. The gorge does not respond to urgency. It waits for alignment of wind load and attention. When the final deck closes the gap, there is no dramatic reveal. The bridge is complete not in a moment, but in a state. Pavement follows. Barriers rise. Systems are tested repeatedly. The structure settles into its working posture. From above, the road appears ordinary again. Lanes align. Traffic markings read familiar. The sensation of height recedes quickly once movement begins. From below, nothing has changed except the presence of a line that now ignores the descent entirely. The scale of construction is not just vertical, it is operational. Every meter of height multiplies coordination. Every hour of work depends on conditions that cannot be negotiated. The bridge exists because sequence held, because hundreds of actions aligned without interruption across a space that offers no recovery once alignment is lost. This is not construction that ends when the last segment is placed. It is construction that succeeds only by anticipating the next adjustment, because at this height, completion is simply the transition into maintenance. The gorge remains. The bridge learns to live above it. Once the bridge opens, the most striking change is how quickly it disappears into routine. Drivers cross it without slowing. Freight schedules adjust silently. What once required careful planning becomes a line item in logistics software, a segment of highway no different from any other except in memory. Height, which dominated construction, fades from perception as soon as movement becomes continuous. For communities on either side of the gorge, time compresses first. Journeys measured in hours collapse into minutes. Markets expand without ceremony. Perishable goods arrive intact. Service vehicles reach places that once felt remote, even within the same county. Distance loses its authority. The bridge alters behavior more than it alters landscape. People choose jobs farther from home because commuting becomes predictable. Businesses reconsider locations that were once dismissed as impractical. Emergency response improves not through new capacity, but through access. Reliability replaces improvisation. For residents who lived with the gorge as a boundary, the psychological shift is subtle. The canyon remains visually present, but it no longer structures decisions. Travel plans no longer orbit around weather forecasts or daylight limits. The terrain stops dictating when movement is possible. Workers who maintain the bridge experience a different reality. For them, the height never normalizes. Inspections are deliberate. Sensors are monitored. Maintenance windows are planned around wind and visibility. The structure's invisibility to users depends on constant attention from those who know how little margin exists above open air. Over time, the bridge becomes part of regional identity, not as spectacle but as expectation. Children grow up crossing it without novelty. New residents inherit it as given. The memory of delay recedes. What remains is dependence. Once movement accelerates, systems reorganize around it. Closing the bridge becomes unthinkable, even temporarily. Detours that once sufficed now feel intolerable. The bridge does not just shorten routes, it raises the cost of interruption. In that sense, daily life does not simply benefit from the structure. It aligns with it. The bridge becomes less a marvel than a requirement, proof that extreme engineering, once absorbed into routine, reshapes what people consider normal, acceptable, and possible. The gorge still exists. It just no longer governs how life moves across it. The bridge works. That fact does not end the argument. It sharpens it. Height never becomes neutral. Wind loads change with weather patterns that shift over decades, not seasons. Temperature gradients expand and contract steel in cycles that no opening ceremony can predict fully. Sensors report constantly, but data does not eliminate uncertainty. It reframes it as something to be watched rather than avoided. Maintenance becomes the quiet cost. At this altitude, routine inspections require extraordinary logistics. Crews operate where access itself is a project. Lane closures ripple through regional traffic because alternatives remain limited. What was once a detour problem becomes a dependency problem. The more essential the bridge becomes, the less tolerance exists for its absence. Geology adds another layer of unease. Karst landscapes are stable until they are not. Water moves invisibly through rock-altering load paths over time. Foundations designed to account for this risk must be reassessed repeatedly as conditions evolve. The gorge is not static. It changes on timelines that outlast construction schedules. Cost comparisons linger in policy discussions. The bridge delivered dramatic time savings, but at a price far higher than incremental upgrades. Critics ask whether resources might have connected more communities if spread across multiple smaller projects. Supporters counter that partial fixes would have preserved fragmentation and that only decisive crossings could realign the network. There is also the question of precedent. As bridges at extreme heights become normalized, expectations shift. What was once exceptional becomes a benchmark. Future projects face pressure to match or exceed scale, even where terrain does not demand it. Engineering restraint becomes harder to justify when success is visible and measurable. None of these concerns negate the bridge's function. They complicate it. The controversy is not about whether the Beipanjiang Bridge should exist. It does. It carries traffic reliably. The deeper question is, how much reliance should be placed on structures whose performance depends on constant vigilance in environments that never stop exerting force? In places where geography once imposed delay, engineering now imposes responsibility. The debate turns on which burden is easier to carry over time. The bridge holds. Traffic moves above the gorge as if height were incidental. Schedules compress. Regions integrate. What was once an obstacle becomes a line item, measured, managed, assumed. But the void beneath does not disappear. It waits. If extreme crossings become routine, where does caution re-enter decision-making? If distance can be erased by height, what new vulnerabilities replace the old ones rooted in terrain? And when entire regions reorganize around single points of passage, how resilient is that efficiency to interruption? The Beipanjiang Bridge does not answer these questions. It reframes them. It shows that geography can be bypassed but not removed. That delay can be traded for dependence. That engineering can suspend movement above limits without dissolving them. The gorge remains what it has always been: deep, indifferent, patient. The bridge proves that human systems can cross it. What remains uncertain is how long those systems will be willing and able to keep doing so without pause.